Let's consider the composite functions f of x equals 1 over x squared and g of x equals x over x minus 5. So in this question, we're going to determine the domain and the range of f of g as well as g of f and compute the intercepts. Okay, so the y-intercepts and the x-intercepts. Okay, so when we're doing this, right, what we want to kind of think about is, let's do f of g first, right? F kind of in this little dot g really just means f of g of x. Okay, and f of g of x means we're going to consider f of x, except everywhere we see x, we're kind of replacing it with this g of x. So g of x is x over x minus 5. So for f of x, anytime we see x, we're just going to put x over x minus 5. So I'll kind of move this down a little bit. This is going to be equal to 1 over x plus 2, except the x is now x over x minus 5 plus 2. Now if we want to kind of get the bottom here into one fraction, right, we have to get a common denominator. So this is the same as 1, actually I'll do it kind of smaller over here, equals 1 over, let's see here, well we need it to be x minus 5, so it'll be x plus 2x minus 10 over x minus 5, right? Because 2 times x minus 5 over x minus 5, what we get here is 2x minus 10, that's that part right here. Our new denominator is x minus 5. We had this x to start, and we were adding it. So when we do this, right, what we really get is 1 over this fraction. So essentially it's just this fraction kind of flipped on the bottom here, because we can bring it out, flip it, and multiply it. So 1 over this is just kind of the bottom part here flipped. So x plus 2x is 3x. So essentially this is just x minus 5 over 3x minus 10. X minus 5 over 3x minus 10. Okay, and we're fairly used to a rational expression like this, and if we were to interpret it graphically, right? If we were to interpret it graphically, the way we could think of it is this 3x minus 10 here, right? If this bottom here is equal to 0, then that means there's an asymptote there. So if we say 3x minus 10 equals 0, then that means x equals 10 over 3. At x equals 10 over 3, there is going to be that vertical asymptote. So if you were going to graph this thing, if this was, say, 10 over 3 right here, there would be a vertical asymptote there. Okay, so the vertical asymptote would be looking like this. Whoops. Kind of looking like that. And then you kind of curve up that way, and there would be an asymptote right there. So let's just look at what the actual question's asking. It's saying, determine the domain or range of f of g, g of f. Okay, this is f of g, right? The domain, right, we're going to say x can be anything at once, except this point right here, right, where we find the asymptote. So x cannot equal 10 over 3. So x is an element of real numbers such that, or we can actually just put a comma, x does not equal 10 over 3. So as long as x isn't 10 over 3, we're good. And the range, right, well, let's think about the range here. Yeah, so because this part right here is an x, this is a 3x, right? We're going to get, like, at some point when we simplify this out, as x gets really big or really small, this will approach x over 3x because these will become inconsequential. So this will kind of eventually become 1 over 3 as the limit of the function as x approaches infinity or negative infinity. So that's also a horizontal asymptote. Okay, so I'm going to put y as an element of real numbers. Actually, it's not even y, I'm going to put f of x. So f is an element of real numbers. And y cannot equal 1/3. So I hope that makes sense, right? Because as x gets really big, the negative 5 and the negative 10 won't matter as much. So remember, we have our asymptote right here, and as the graph kind of flattens out, right, this is going to be this graph right here, or this horizontal asymptote is going to be 1 over 3, and this is going to be 10 over 3. Okay, and it also wants the intercepts. So if we know that this is our kind of simplified equation here for f of g, well, the intercepts, right, if we want, for example, the x-intercepts, that's when the y value is 0, and the y value is 0 when this numerator is 0. So if x minus 5 is 0, that means x is equal to 5. So when x is 5, that's where our x-intercepts are going to be. So there's only one x-intercept on this graph. And for the y-intercept, that's when the x is 0. So if we were to plug in 0 for x, we would get 0 minus 5, which is negative 5, over 0 minus 10, which is negative 10. So that'll be positive 1/2. Okay, so I'll call this right here part A. And then part B, right, that's for g of f of x. So g and then this little O of f, this equals g of f of x, right? And so now we're just going to look at the function g, and every time we see x, we're going to replace it with 1 over x plus 2. So it's going to be 1 over x plus 2 over 1 over x plus 2 over 1 over x plus 2 minus 5. Move it over a bit, so 1 over x plus 2 minus 5, and as always, we want to make this one fraction. Need common denominators, so negative 5, we multiply that by x plus 2 over x plus 2. We get negative 5x minus 10 over x plus 2. Okay, and then we add 1 to that, right? So it's going to be negative 5x minus 9 over x plus 2. So 1 over x plus 2 over negative 5x minus 9 over x plus 2. Now remember, if we have a fraction divided by a fraction, we just bring this out, flip it, and multiply it. X plus 2's are going to cancel, and we're just going to get 1 over negative 5x minus 9. Now since this is a 1, the numerator is never going to equal 0, so an x-intercept actually doesn't exist, because if we were to graph this, there's a horizontal asymptote at 0. Okay, so when the y value is 0, x doesn't exist, because there's no point x where the y value is going to equal 0. Okay, so no matter how big this denominator is, never going to quite equal 0. Now, as for the x-intercepts, the y-intercepts, the y-intercept is when x is equal to 0, so this will be 1 over negative 5 times 0, so 0 minus 9. So the y-intercept will be negative 1 over 9, so that'll be right there. And then as for the horizontal asymptotes, that's always when negative 5x minus 9 equals 0. So that's when the denominator equals 0. So that means we can divide both sides by negative 1. So x will be positive 9 over 5. So that's going to be kind of right here. So vertical asymptote. And we can kind of picture what this graph's going to look like. It's going to look something like this. Something like this. Right? And so in terms of the domain and range, we would say that x is an element of the real numbers. So x is an element of the real numbers so long as x does not equal 9 over 5, because that's our vertical asymptote. And then g is an element of the real numbers so long that g does not equal 0. And I keep writing y. What I should really be writing is g. I think I wrote y up here, yeah. So I just call it y out of habit, but it really is g and f. So it's good to kind of reference those. So I hope that makes sense. That's how we can kind of interpret it graphically, right, of these composite functions. Really, we're just plugging in one function in for the other function's independent variable, just simplifying that, and then we kind of get a function out of that itself that we can graph and interpret, the intercepts, the end behavior, the domain, the range, all that good stuff. So hope that makes sense. And yeah, that's kind of my concluding lesson kind of compilation of composite functions. So I hope that made sense. And I'll kind of do a harder question in my next video on composite functions. Thanks for listening.